Hello everyone, I hope you are all doing great. Today we are going through an interesting challenge which is Pascal triangle 2. So basically in this problem you will receive as input a row index which represents the row index of Pascal triangle, and you're supposed to return the value, in fact the vector or the array at that row index. The main thing here is to be able to understand exactly how Pascal triangle work and be able to implement something which is going to build it and just return now the value corresponding of the row you receive as input. So before we dive into understanding exactly how Pascal triangle work, I really encourage you to subscribe to do not miss what you are doing here, because you are doing LeetCode daily occurring solution. And down in the description below you have a link to Discord server, so if you're interested in any discussion related to coding, don't hesitate to join. Okay, so now let's dive into the core logic of our problem. So basically, as you can see here, Pascal triangle is basically a scenario where we have, I would say, two elements. We have two static element with 1 and 1, and each of the row are actually built based on the previous row. What does that mean exactly? That means for each of the rows you actually put the first and the last one to 1, and then for each of the element in between the first and the last one you build it based on the sum of the two previous one. That means this one is going to be the sum of this and this. That means element at position 1 is going to be the sum of the previous element at position 1 plus the previous element at position 1 minus 1. That's why you have this. This one, element at position 1, is going to be the previous element at position 1 plus element at position 1 minus 1, 0. This one is going to be element at position 2 plus element at position 1. So basically that is how you compute each of the element. So let us have a representation and see how it will look like. So we have the first element, which is 1, we have the second row, which is 1 1, and then now we have our third row. Now is 0 base, that is why the third row is identified by 2. So I'll start the first and the last to 1, and then I will loop through the element. I will say, okay, this element is element at position 1. It's going to be the sum of the previous element at position 1, which is this one, plus element at position 1 minus 1, this one. So we are going to have a 2 here, right? We are going to have a 2 here. Now if you have a third row here, how are we going to compute the third row? The third row, eventually we are going to start with 1 and end with 1, as we were saying. Now the element here is going to be, let me take another color. The element here is going to be the sum of this plus this, which is 3. The element here is going to be the sum of this plus this, which is 3. And then here we are ending. And then the last one we are going to take, just for you to understand how it's work, we are going to take for 4. So for 4 we are going to say this element is actually this plus this, which is 4. This element is going to be this plus this, which is actually 6, and this element is going to be this plus this, which is 4. So basically that is how you build your Pascal triangle. And then at this stage what you're supposed to do is to return the element at the row index corresponding to your input. Let's say your input was 2. If your input was 2, you should return this array. If your input was instead 3, you should return this array. So basically that is what you're supposed to do now. Since we are aware of how the thing is working, how are we going to implement such array? How are we going to implement such logic? What is our approach of implementing this? So for implementing this, I'm going to have a vector which is going to which I'm going to initialize at 1. I'm going to initialize my vector with those two elements, but basically you can just do with 1. I did with those two elements, but I'm going to update it and we are going to see exactly how it behaves, and I think it will still work. So you initialize your vector, and after that you are going to loop from 2 till the row index, and for each of the element you now compute the element in between the first and the last one. And then since the left and the right need to be 1, now for you to efficiently compute the element in between the first and the last one and have the accurate result, you need to initialize your vector with 1s. That means everything at 1, and then you just update the value in between the first and the last one. So what does it look like? So I have my vector here that I'm initializing. I'm pushing the first element to be 1. I was saying that I don't really need this, I think. And then I can start at 1. So why am I saying that? Now here I'm creating a vector, a temporary vector, which has a size of the row index plus 1. Why? Because if I'm here at row 1, I'm expecting to have a vector of size 2. If I'm here at row 2, I'm expecting to have a vector of size 3. So that's why I'm creating that vector. And here, after creating the vector for this case, now I will try to loop from element. I'm trying to loop from element at position 1 till G is less than E. So this element I is already equal to 1, so this loop is eventually going to provide nothing. So the temporary vector is going to be 1, 2, which is the value that is going to be append here. And for the next value, I'm eventually going to have element that is going to be found in this for loop, which is going to be the middle element before pushing. So basically this is my approach of implementing this. Let us run and see how it behaves. So like we were saying, this is actually returning the accurate result. So this is my approach of solving this. I hope you do enjoy it. Feel free to leave me any input. I'll be really happy to interact with you regarding this. We can say that this is performing actually well. Hope you enjoy it. See you on the next video. Don't forget to like, share and subscribe.